Welcome to day 12, where we are going to explore some topics that are honestly probably my favorite topics in the competition math curriculum. We're going to be looking at different bases, and by bases I mean like how our number system is a base 10, right? We go up by tens, which build to hundreds and thousands and so on. We're going to look at units, digits, fractions, and decimals. There's some good competition math tricks to make yourself faster here. And we're going to look at something called modular arithmetic. So those are our three big topics, and we're first going to start with bases. And this is where I always tell students, you're going to think that you know how to add and subtract things, and then I'm going to make it harder, and you're going to start doubting if you know how to add and subtract properly. And this is actually a really interesting one, and I think as a teacher, it's really interesting because thinking about how to teach kids adding, I think of adding as such an obvious topic at this stage, and I'm sure many of you, or all of you guys do as well. Like, teaching how to add seems kind of mundane, but teaching how to add with different bases other than 10 kind of helps you appreciate what, maybe your siblings are learning if they're learning how to add and subtract. So it can help you appreciate how difficult it must be for them at first. So we have 10 fingers and 10 toes, which is probably why we have a number system that uses 10 digits. The first digit to the left of our decimal point, so here's my, example. So first digit to the left of a decimal point is 10 to the 0, which is 1. That's our ones digits. The second digit is 10 to the first, which is 10. It's our tens place. The third digit is 10 squared, which is 100. So in our base system, here's a cool example. If I look at 352, that is 3 10 to the 10 squared, which is 3 hundredths. 5 10 to the first powers, which is 5 tens. And then 2 10 to the 0, which is 2 ones. And so putting those together, you get the 300, the 50, and the 2, which is kind of interesting to think through. I don't think anyone ever really explained how this fits into our decimals and our digits. So for examples, let's look at some examples. When 10 fingers and 10 toes, with 10 fingers and 10 toes, we have the digits 0 to 9. Right? Suppose we were born with 6 fingers and 6 toes. Based upon that, and we use that as our basis for our numbering system, what would our numbers look like? How many digits would we use? Okay, so if you had 6 as your base, it's kind of weird to think about, but using our 10 digits, right? To make it 10, we really use a 1 and a 0, right? In order to say that we've gotten to a 10. So it's everything from 0 up to the number in front of that. So if I only had 6 digits, that would be 0 to 5, which is kind of weird to think about. And then they ask us, what would the first 3 digits in a 3-digit number represent? So if I think about 3 digits, right? This one, if we follow the formatting, instead of 10, it would be 6 to the 0, which is 1. So this is our ones place, right? So sometimes I like doing like just ones place, like that. This one would be 6 to the first. So this is our sixes place. And this would be 6 squared. So this would be our 36s. It's really weird to think about. And that's counter to our ones, tens, and hundreds. So think about it in the sense that when I transition from 99 to 100, right, the 100 is there to say that I've gotten 10 of these, so I make one of those. So it's kind of like if you had 6 of these, you would put one of those, and 6 sixes is 36. It's really weird to think about, because we're so comfortable and we don't really have to think about it for our number system. So try to write the number 12 in base 6. Okay, so let's try 12 in base 6 and 37 in base 6. Okay, so if I think through, we have our 1s, 6s, and 36s. And you always want to see if you have like 36, right? You would put a 1 in the 36th place. So you always look at where you have the largest number, right? If I have 36s, I would start with 36s. Or even if it was, 1 decimal space further. But obviously, since it's 12, it's not a huge number. So I don't have any 36s. 12 is 2 6s, right? 2 6s. So I could put a 2 here, and that's the entire number. There are no 36s, there are no 1s. So 12 base 6 would be the same thing as 20. And actually, I'm going to say like 12 base 10 maybe is 20 base 6, just to kind of compare what it looks like in each base. So 37 base 10 is blank in base 6. So let's see. And I always do the same thing. I always kind of have to write this out for myself. And I say, okay, do I have any 36s? Yes, I do. So I could do 37, take away 36. So I put 1 in the 36s. That leaves 1 1 and no 6s. So it's 101 in base 6. So it's really interesting to think about that, in this case, 101 base 6 is the same thing as a 37 in base 10. And it's just kind of weird to think about because we take a lot longer in order to get to a 3-digit number in the base 10 system. But if you think about it, in our base 6 system, you have smaller numbers that you need to obtain before you get to the third space because it is a smaller base, right? If I tried a base of 20, it would take a lot longer for me to get to my third digit. Kind of interesting, right? So here's some notation on bases. To represent a number in a different base, a subscript is used. So I might say 123 base 4, but it would be noted like this. So here's kind of what it looks like. We might say that this is 123 base 4, which is the same thing as something in base 10, right? And we're looking for what the base 10 number would be. So in this case, we're kind of going backwards, in the opposite direction of what we did before. So let's think about, we have a 3-digit number, and our base is 4. So this is 4 to the 0, which is our 1s. This is 4 to the first, which is our 4s, and 4 squared, which is 16. So if I have 123, that means I have 1, 16, plus 2, 4s, plus 3, 1s. Oops, I don't really have to write the 1. Right? And notice where this is coming from, right? From there, and there, oops, wrong thing, and there. And then the other numbers are coming just from knowing what each space is. So that will simplify to 16 plus 8 plus 3. So that's 16 plus 11. So it looks like it's 27 base 10. So remember, similar to before, anytime I go from like a little base, like base 4, base 6, to a base 10, it should be a smaller number, right? Because it takes more to get to a new digit in a base 10 than it would in a base 4. So it does kind of make sense that we are now only a 2-digit number rather than a 3-digit number. Okay, same kind of question. Why don't you guys try number 2 on your own? Go ahead and pause the video, work through, unpause when you're ready to check. Okay, so here is your worked out answer. It is actually 155 base 10. And I think actually it's probably easier to do this version than to do like starting in a base 10 and going to a new base. I think it's a little bit harder because you have to think through what number goes in which space. This one you just figure out the spaces and just do quick multiplication. So I think this is a little bit easier than the previous kinds of problems we were looking at. So now we're going to do just really simple, straightforward arithmetic in base, different bases. Okay, And oftentimes when I do these kind of problems, I do prefer to kind of think back to a base 10 example and like do a similar problem on the side and, you know, think through what goes through my head without even thinking sometimes. So we're going to complete the exercise to find the easy way to multiply a base 5 number times 5. Okay, so convert 14 and 70 to base 5. And just kind of something to think about. 14 times 5 is 70. So we're kind of thinking about what happens when you multiply by the number that is the base, right? So 14 and 70 into base 5. And base 5, I'm just going to do this every time. 5 to the 0 is 1's place, 5 to the first is 5's, and 5 squared equals 25's. Okay, so 14 in base 10, I'm not quite at this ability to put a 25. So 14 base 10 is equal to, let's see, I've got 2 5's, right? So I know I can put a 2. And then once I take away 2 of my 5's, I'm left with 4. So it'd be 24 base 5. And 70 base 10. Let's see, 70 has got 25. So let's think about what the next digit is just in case. That'd be 5 cubed, which is 125. So that's too big. So 70 has, let's see, 2 5's, right? Or 2 25's, excuse me. So if I do 70 minus 25 minus 25, that's taking away 50, and I'm left with 20. And 20 is 4 5's, so I can call it 240. Notice, right, 2 25's, 4 5's, no 1's. You can't just forget about that last space, otherwise you're saying it's a different size. And so do you guys notice how to get from here to here? It's actually the same thing as what happens in a base 10 system, right? So like think about in base 10, when you multiply by 10, remember that trick is you add a 0, right? The same thing actually works here, which is really, really interesting. And it's kind of cool to think about how that works in other number systems, not just ours. Okay. And then, oh, I kind of spoiled the beans. I didn't realize there was a second example. So try out this next example just to confirm the pattern that we are thinking we're seeing. So worked it out. It follows the same pattern we just saw. So I just kind of wrote down what we already said in part A, which is like when you multiply by 5 in base 5, you can just add a 0 to the end of the number. You could also generalize this and say like when you multiply by n in base n. And that's just being a stand-in saying that it could be any base. It doesn't have to be just a base 5. Okay, so we're going to complete the following exercises to find if there's any fast shortcuts to add numbers in different bases. Okay, so what I want to do is we're going to convert 112 base 6 and 23 base 6 to base 10, right? So we're going to take base 6's, make them base 10. Then we're going to add them. Then we're going to switch them back to base 6 and see if there's any shortcuts we're noticing. Okay? So I think you guys can do A and B on your own based on our new knowledge of bases and how to rewrite them. Okay, so try that on your own. So I did part A and B all the way through. Feel free to pause the video if you want to like double check any small things. What I did here was I kind of expanded 59 base 10 into groups starting with 36. I took away 136. I couldn't take away 2 because 2 times 36 is bigger than 59. I was left with 23, which I knew that 3 6's went into to make 18. So that's where the next part comes from. And then I was left with 5 over. So I kind of grouped them into those prior to putting like my numbers, like 3 of those, 5 1s, just to kind of make it a little easier to see how I got that. And then what can you conclude? It's the same rule as adding in base 10. Okay, so what we're going to do in the next video, since I'm running out of time in this one, is we're going to practice adding and subtracting. And it gets a little tricky with borrowing, but we're going to work through that and like think about how we borrow in base 10s. Okay, so I'll see you guys in the next video.